Gilles de Roberval, who lived from 1602 to 1675, was a French mathematician and physicist known for his contributions to geometry, mechanics, and the early development of calculus. A professor at the prestigious Collège de France, Roberval was one of the leading figures in 17th century mathematics. His inventive techniques and concepts influenced the study of curves, motion, and fluid mechanics. Though some of his ideas were overshadowed by contemporaries like René Descartes and Pierre de Fermat, Roberval's work remains significant in the history of mathematics. Gilles Person de Roberval was born on August 10, 1602 in Roberval, a small village in the Oise region of France. Little is known about his early life, but he displayed an aptitude for mathematics from a young age. Roberval's intellectual journey led him to Paris, where he became associated with leading thinkers of the time, including Marin Mersenne, who introduced him to the broader European network of mathematicians and scientists. In 1631, Roberval was appointed to the chair of mathematics at the Collège de France, a position he held for over 4 decades. His tenure at the college allowed him to pursue his research and experiment with innovative ideas in mathematics and physics. The method of indivisibles. Roberval made significant advancements in indivisible geometry, a technique introduced by Bonaventura Cavalieri for analyzing areas and volumes. Roberval expanded on this concept to investigate curves and surfaces. His method involved decomposing geometric figures into an infinite number of infinitely small parts, indivisibles, and summing them to determine areas or volumes. For example, Roberval calculated the area under curves like the cycloid using this approach. Though his methods lacked the formal rigor of modern calculus, they provided important insights and laid the groundwork for the eventual development of integration. The cycloid. The cycloid, the curve traced by a point on the rim of a rolling circle, fascinated Roberval and many mathematicians of his era. Roberval was the first to calculate the area under the cycloid, demonstrating that it is 3 times the area of the generating circle. His solution, based on his indivisible geometry, was a remarkable achievement that showcased his skill in analyzing curves. The cycloid later gained importance in physics and mechanics, including its application to pendulums and the design of tautochrone curves. Transformations in geometry. Roberval also contributed to the study of geometric transformations, particularly the use of rotation to analyze curves. His innovative methods allowed him to explore the relationships between curves and their tangents, anticipating ideas that would later be formalized in calculus. These studies were influential in advancing the understanding of motion and dynamics in the 17th century. One of Roberval's most enduring inventions is the Roberval balance, a type of weighing scale that remains in use today. This device consists of 2 horizontal arms attached to a vertical beam, with the arms moving in parallel regardless of the distribution of weight. The design ensures accurate measurements even when the weights are not placed symmetrically. The Roberval balance was a practical application of Roberval's deep understanding of mechanical equilibrium, and it exemplified his ability to translate theoretical principles into useful devices. Roberval conducted pioneering work in dynamics, particularly in the study of moving bodies. He explored the relationship between force, motion, and resistance, contributing to the early understanding of mechanics. His experiments with pendulums and other oscillating systems anticipated the later work of Galileo Galilei and Christian Huygens on motion and timekeeping. Roberval worked during a time of intense competition among mathematicians, many of whom were vying for recognition and prestige. His rivalry with René Descartes is well documented. Roberval often criticized Descartes' methods and philosophical approach. Unlike Descartes, who emphasized algebraic solutions, Roberval preferred geometric methods rooted in classical traditions. This rivalry extended to disputes over priority in mathematical discoveries. Roberval's reluctance to publish his findings promptly meant that others, including Fermat and Pascal, sometimes received credit for similar ideas. Despite this, Roberval's contributions were widely recognized within the academic community of his time. Although overshadowed by some of his contemporaries, Gilles de Roberval made lasting contributions to mathematics and science. Roberval's work with indivisibles and transformations advanced the understanding of curves and motion, bridging the gap between classical geometry and early calculus. The Roberval balance remains a practical tool in various industries, demonstrating the enduring relevance of his mechanical ingenuity. His studies on the cycloid and motion influenced later developments in physics, particularly in the fields of mechanics and fluid dynamics. As a professor at the Collège de France, Roberval inspired generations of students and mathematicians, helping to disseminate the new mathematical ideas of the scientific revolution. Gilles de Roberval's life and work exemplify the spirit of innovation and curiosity that defined the scientific revolution. Through his contributions to geometry, mechanics, and mathematical methods, Roberval helped shape the trajectory of modern science and mathematics. His inventive approach to problems like the cycloid and his practical invention of the Roberval balance reflect his versatility and creativity as a thinker. While his achievements were sometimes eclipsed by contemporaries like Descartes and Fermat, Roberval's legacy endures in the tools, concepts, and methods that continue to influence mathematics and science today. His life serves as a reminder of the collaborative and competitive environment that propelled 17th century intellectual progress, marking him as a key figure in the history of mathematics.